Hey everyone, I wanted to walk you through the 4.8 chapter project. So when we go into Mom, whether you're on my anytime class or if you're in my 10 a.m. class, it's going to look the same. So you should see that you have chapter 4.8 discrete distributions, and that's going to be due on Thursday at 11:59 p.m. And the way that we're going to submit it is going to be through OneNote, just like we've done with other works. So there's a couple ways you can access it. One, if you click on the chapter 4.8 chapter project, you can get a link to the instructions. So if I click this, it'll open up all the instructions. So again, just a reminder how to build a frequency table, how to insert charts, how to make a histogram, how to do your standard deviation. And then we're also going to be leaning very heavily on 4.2 and 4.3. So if you want to rewatch those lectures, you can. There's a template for you. So you want to go ahead and download the template. And then when you submit your work, again, you want to go into your folder on OneNote, into chapter projects. And then you want to insert, share, or in some way upload your work to the page 4.8 discrete distribution. So one way to get there, again, is clicking on the calendar. Another way to get there is if you scroll down, you'll see that we have 4.2 and 4.3 here with the lecture videos that you may want to watch to refresh. Also the instructional video for the Excel sheet, which you may find useful for this project. But below all this is the same thing we just saw. So in any case, we download the document. And this is going to be a Word document. So when I open up my Word document, it launches in the software. However, you're also welcome to open it from the web-based software. So to do that, you could go to office.com and you would want to find, upload and open. You'd want to find where you downloaded that file to. Select it, and it'll upload and open for you here. Mine's already in my OneDrive. So I can upload and edit here. So here's what it looks like. Everywhere in green are fields that you want to make sure that you fill in. The tables, obviously, we're going to be filling those in, but I thought they were overt enough that they didn't warrant a full green highlight. But there's some stuff kind of embedded in the text. So the first thing we want to do is kind of just understand what the goal is. So the goal is to look at some empirical data, right? Do an experiment, actually roll some dice, record the data, and look at that frequency distribution. And then we want to shift gears into the theoretical data, which is what we know, what we would expect the long-term outcome to be, right? So the process is we're going to roll one die, and that's going to be our lucky die. And then we're going to roll 3 die, and we're going to see how many matches we get to our lucky die. So if I were doing this, if you don't have dice, these are random, these are like virtual dice, which is kind of cool. So you can also visit the site for like virtual cards and other fun stuff. So I would go here to roll my single dice. And it opens up random.org. Okay, so I'm gonna roll my dice. Okay, great, so I got a 5. So 5 is my lucky die. So I were to record here, I would say that this is 5. Okay, and then what I wanna do is I wanna roll 3 dice, and I wanna see I want to see how many of them match. So I'm actually going to do a side-by-side here. So we'll do that, and then we'll go here. Excuse you. So I've got my dice roller on the right. So I rolled a 5, 6, 6. So I'm going to record that. And then I'm going to say, okay, well, how many of those are a 5? One of them. Okay, now I'm going to repeat the process, roll again. Okay, and this time I got a 6, 2, 2, which that's 0. There's no 5s in there. And then I'm going to roll it again, a 2, 4, and a 6. So I got 0. I'm going to go ahead and say that this die is not very lucky, this 5. Okay, so 2, 6, 2, that's also 0. Ah, there we are. A 6, 5, 5. So I got 2. 1, 1, 1. So that's another 0. Right? So again, I'm just counting the number of 5s that I get. And I'm going to do this until I have this table all filled out, right? So I want to do 10 rolls like this. I'm going to fill out this table. And this becomes like, this is our raw data. And so now what I want to do, well, okay, let's finish filling out the table just so I can show you how to do the next part. So 6, 2, 3, that's another 0. Oh my goodness, 4, 6, 1. Some of you might say, what are the odds? But now that you're in statistics, you can actually compute the odds for yourself. Wow, pretty low. Oh my gosh. The game is rigged, you guys. All right, anyway. So now that I have my raw data, what I'm going to do is I'm going to put that data into a frequency distribution table. So first of all, we've rolled 10 times, right? So we know that when I'm doing my relative frequency, it's going to be out of 10. So, okay, how many zeros did I get? A lot. 1, 2, 3, 4, 5, 6, 7, 8. I got 8. And so my relative frequency is 8 out of 10. Or I could say it's equal to 0.8. However you want to format that is fine with me. Okay, how many times did I get one match? Once. So that was equal to 1 out of 10, or I could write 0.1. How many times did I get 2? Once. So that would be 1 out of 10. And then how many times did I get 3 matches? Never happened. So this is 0. Yeah, sad. Okay. So what I want to do now that I have my data, I want to organize it. So I think for me, what I would do is I would probably go over to Excel because I want to make a histogram for this. I want to compute the mean for this. I want to compute the sample standard deviation for this. And then once I've done all that, right? So let's say I've done all this work, right? Great. I'm really mathing really hard over here. So once I've done all my work, I want to share my file as a link. So if I do that, make sure to, if your link doesn't automatically come up, go ahead and upload your work to OneDrive and name it something more appropriate than work, work, work. Once you do that, then you'll be able to share a link. Great. So you want to click on copy link and then actually copy the link. And then you're going to go ahead and insert it here into this green field. Okay, great. And make sure that, you're putting in, so this green field here, that's where I want you to put in your histogram. This green field here, that's where I want you to put in your X bar. Here's where I want you to put in your sample standard deviation. So now that you've done that, you've worked your empirical data. Now we're going to go into theoretical data. So here's probably the trickier part. We want to create a probability distribution function where the random variable x is the number of matches to your lucky die. So this is very much 4.3, right? So success is going to be your individual trials are just one die out of the three. So let's go back to our random die thing. The first die, this is an independent trial where success for me would be rolling a 5 and failure would be rolling not a 5. My probability of success, well, what's the probability of rolling a 5 on any single die? That's what we got to figure out. And then I have how many trials, right? So we can see we have rolling 3 dice, so we're going to have 3 trials. So we need to put this in the context of binomial distribution. So we need to know the number of trials n, which is 3. And we need to know the probability of success. And so that's going to be the probability of any one die matching your lucky die. Once we get our probability distribution function, we're going to create a histogram for it. We're going to compute the mean and the standard deviation. Now remember that the mean and the standard deviation for a binomial distribution are given to us very nicely. So you can review the 4.3 notes on that if you need to. If you're computing it with a table, that's the long way to do it. So make sure you look up how to compute mean and standard deviation for binomial distribution. And then the last part's just going to be an analysis. So we want to compare and contrast your empirical data to your theoretical data. Just talk about if it's different, why it's different. And then I want us to really focus on how X bar is different in its meaning from mu and how S is different in its meaning from sigma. And then if you want to earn a little bit of extra credit on this, you can see if you can make a bar chart in Excel that shows both the theoretical data and the empirical data on the same axis, right? So because you're going to have a histogram for your actual 10 rolls, and then you're also going to have a histogram for your theoretical data using the binomial distribution. If you can put both of those on the same axis, great, it's extra credit. Don't ask me for help, I'm not going to help you, but only because it's extra credit. Everything else is fair game. Good luck. If you have questions, definitely email me. Oh,